My name is Caroline Moore, and I'm here to talk to you about statics. No, not static electricity. This is the study of interactions between forces and members during static equilibrium. Don't worry, that's just a fancy word for when something is calculated at a single snapshot in time. Think about a house. This house needs to be able to hold a roof above their heads and the floor beneath their feet. Now, the dad can't just hold up the roof up by himself. There needs to be supports and beams that keep the roof and floor stationary so this kinds of things don't happen. To make sure this house, and any building for that matter, is safe and sturdy, you first must know about centroids. A centroid is the arithmetic mean position of all points of a shape. Let's take a square for example. The equations you will need are x bar and y bar. X bar deals with the base of the shape, and you can easily remember this because it parallels the x-axis. Y bar deals with the height and has the same easy trick. It parallels with the y-axis. The values for x bar and y bar will become the ordered pair of the centroid. For a square, the centroid will be located right about here. Now let's look at a triangle. X bar and y bar correspond with the same h and b variables of a square. X bar equals b over 3, and y bar equals h over 3. The y-axis and the x-axis correspond the same. The centroid will be right about here. So why are we calculating these centroids again? It's because engineers need to know where the average mass of an object is going to fall, and subsequently make better materials that evenly distribute the weight more effectively. If I was building something involving beams, like the foundation of a house, I don't want to bounce on the floors like it was a trampoline. This would lead to permanent deformation, something engineers definitely want to avoid. Let's see this in action. This is a plank beam. As you can see, it deforms very easily. This is a joint beam. It does not deform very easily. So yada yada yada. Why is this important? Here's a real-life example. A car is driving along a bridge. Civil engineers have to make sure their great creations are sturdy enough to support vehicles that are on average about 4,000 pounds apiece. Calculating centroids, the average position of the weight, will be helpful in identifying how the bridge should respond to the force of the car. A car's centroid would be very time-consuming to calculate, but let's just say it's here. This is where the average weight of the car will be distributed in the middle of the bridge at a moment in time. This free body diagram consists of W, the applied weight force exerted by the car on the bridge. F1 and F2 are the supports of the bridge. These push identical resistance forces towards the car. Hope you learned more than you knew yesterday. Thanks for watching.